Hi guys, this is the video for chapter 10, lesson 7. So hopefully you have your study guide in front of you, but we're gonna continue to look at circles. And so I would encourage you to take out your notes and we're gonna take a look at segments in a circle, special segments in a circle. So if I have two secants that are intersecting inside my circle, something that's kind of interesting is that the parts that are created by the intersection, so see how this secant now has become two parts, A, B, and then this secant has now become two parts, C and D. Well, what's interesting is that the product of those two parts of the circle are always going to be congruent. So basically A times B is equivalent to C times D. And so they don't have to intersect in the center. As long as they intersect at any part inside the circle, those parts of the circle, the product of the parts of the segment will be equal. So I'm going to kind of write this down. Segments intersecting inside the circle. Basically, that's the description. Okay, segments intersecting inside the circle. If two chords intersect in a circle, then the products of the length of the chord segments are equal. So let's test this out. Let's take a look at our study guide for a second and let's test this out. So let's say that, let's look at our example here. Let's say that we have 3 and 8 over here and 6 and a certain amount over here. We don't know what it is. And so using this idea, we can do 6 times x equals 3 times 8. So that's written right here. And the products should be equal. So 6 times whatever should equal the same thing as 3 times 8. And 3 times 8 is 24. So that means if we work backwards and get x, x is 4. And so you can figure out that x equals 4 here. And so those products are going to be the same. Okay, so let's use this idea to work out our problems on number 1. So basically the two parts of my chord here are 3 times 6, and then the two parts of my other chord are 2 times x. So 3 times 6 is 18, and then 2 times x, I'm gonna work backwards, and this would become 9. And in fact, if I do 2 times 9, it's 18, and 3 times 6 is 18 as well. Let's take a look at if we have segments that are perpendicular, okay? So if I have segments that are perpendicular, that is not going to make a difference for me really because the two parts, I know the product of those two parts will also be equal to the product of the other part, except for we kind of have to piece this information together because I've got this radius as 10 and this little segment here says it's 2. And so we've got to kind of think through, what is this little part? Okay, what's this little part going to be? So if I think through, okay, this entire thing is 10, that's the radius. I subtract this little part, that's 8, which means this whole length from where it's intersected to the end of the circle is 10 and 8, which is 18. So the entire segment that is the entire chord, the two parts of the two chord where it's intersected is 18 times 2. So be very careful with that. You've got to make sure you're looking at the actual part that's being cut by the intersection. So that's actually being cut by the intersection. So looking at this, we've got x squared, really, x times x is x squared, right? And then 18 times 2. So 18 times 2 is 36, square root both sides, x is 6. And so the entire x equals 6. Okay, number 3 is a little more straightforward. So let's take a look at this. We've got 8 times 8 equals 6 times x. 8 times 8, 64. 6x, so we divide by 6 on both sides, and we're going to have a remainder, a decimal answer, right? So working that out, it is 10.7. Okay, number 4. So same idea, just put in the okay, looking at our next problem. Number 4 is a little bit tricky. I'm just gonna give you a heads up. It brings in the idea of factoring your equation. And so we haven't done that all year. And I know you learned this last year, but it's been a long time. So let's just set up our equation first. Don't be intimidated by just setting up the equation. Our two parts of this segment here are 3 and 6. And then our two parts here are x and x plus 7. So x times x plus 7. Now I've got x times x plus 7, so I have to distribute this in and expand that out. 3 times 6 is 18, so I'm going to simplify that and make that 18. And then I have x squared plus 7x. Now, when I see this pattern, x squared plus something x, and then a number over here, I can bring that over, subtract it onto the other side, and now I can see if I can factor this out. So see if we remember how to factor. So I like using the factor tree. And the way I do it is I look at, this is basically, I have my number negative 18. I'm going to factor that out and see what two numbers, if I multiply them, equals negative 18, but when I add them together, equals positive 7. So I'm going to think through. I could do 1 and 18. I could do 2 and 9, right? Now 2 and 9 kind of stands out to me. If I subtract one of the two, like 9 minus 2, so if I make this a negative 9 minus 2, I get positive 7. So that is that middle term that I'm looking for. So now I'm going to write this as x minus 2 times x plus 9. These are my factors. So when I multiply negative 2 times 9, I get negative 18. But when I add them together, I get positive 7. So that means when I set this up as my equation, I have 0 equals x minus 2. And then I have 0 equals x plus 9. Now, if I find out what x is, I add 2 to both sides. 2 equals x here. And then I add or subtract 9 to both sides. I get negative 9 here. So looking at this, the only possibility for my answer is to have a positive number, because I can't have a positive distance of x, right? Like this little part, I can't say that that equals negative 9. So the logical answer is that my answer is 2, okay? And so x equals 2 for this problem. Okay, I don't know if we'll do too many like this. This kind of just randomly came up. We'll see if another one appears, but I did want to go over it with you and review how to factor your equations first, so that if you do see one on your homework or something, you know how to do it. Okay, so looking at number 5, we've got intersection at the center, which means all the parts are actually a radius, right? Those are congruent parts. So I have 5 and 5, and then x plus 2 and x plus 2. They're going to be congruent. So I have 5 times 5 equals x plus 2 times x plus 2. Okay, now this is a tricky too because we have to multiply every single part. And I like drawing the monkey face. So I don't know if your teachers taught you this, but I draw the little monkey face. There's a little nose and the, you know. And so now I'm going to multiply all the parts. So x times x is x squared. 2 times x is 2x. And then I have 2 times x again, plus 2x, plus 2 times 2, which is 4. So I've multiplied all of them and I'm adding them all together. They're just sums. And so now I have 25 equals x squared plus 2x, or sorry, 2x plus 2x is 4x plus 4. Now I need to subtract 25 on both sides so that I get 0 over here and I just have my equation right here. And so I have negative 21. So I need to think through, can I factor out negative 21 where I have a sum that adds up to be positive 4? So if I think through this, 3 times 7 is 21, right? So let me think, which one am I going to make negative? So when I add them, makes it positive 4. So negative 3 plus 7 is positive 4. So my factor here would be x minus 3 and x plus 7. And when I actually work out my x values, I have x equals positive 3 and x equals negative 7, which does not work for us because I don't want to have a negative value when I work this out, right? If I plug it in place of x, negative 7 plus 2 is negative 5, and I'd have a negative 5 for that radius, and that doesn't make sense. So I can also check my work and say, okay, well, if I put in 3 in place of 2, well, that should be 5. And actually, as I'm looking at this, I'm realizing, oh my goodness, I did way too much work for this problem, didn't I? Because these are all a radius, which means they are all equal. So honestly, I probably could have made my life easier by saying 5 equals x plus 2, subtracted 2 on both sides, and x equals 3. So that also is the same answer as what I did when I factored. So at least this verifies that when I factored it, I got the right thing. But after I factor, I realized the fact that I just did way too much work when all radii are congruent within the same circle. So I really could say 5 equals x plus 2 and work that out. So let's take a look at number 6. It's very similar to number 2 like we did up there. I'm going to just erase some of this stuff so I have some more room. But maybe I'll use a different color so it stands out as well too. I'll use purple. So number 6 here, we first have to decide, well, okay, this is x, and this is going to be x as well, because we know this to be true by a chord being bisected by a radius, and that's something we learned from a previous lesson, but these two are going to be congruent. But then now we need to know, okay, what is this little part going to be? Because our radius is 7, and so this part is 2, I think, right? 7 minus 2 is 5. So this little part is 5, which means the entire segment here that's being split would be 5 plus 7, so that's 12. So we need to think through this as 2 times 12 equals x times x. Okay, so 2 times 12 is 24. X times x is x squared. I need to square root both sides. And it looks like this is not going to come out to be a perfect square because 24 is not a perfect square. So I'm just going to plug this in my calculator and write it as a decimal. So square rooting 24 is about 4.9 rounded. So your answer is, let's just round it to the nearest tenth like we did on the other one, 4.9. Okay, number 7, same idea here. Let's set up our equation. 5 times 6 equals 2x times 3x. Okay, so when we multiply this, 5 times 6 or 6 times 5 is 30. And then when I multiply this, I get 6x squared. And so I'm going to divide by 6 on both sides. So I get 5 equals x squared. And now I need to square root it. So just plug it in your calculator, and square root of 5 is about 2.2. And so don't be intimidated by the squares. You guys know how to work that out. So I'm just showing you how to do that here. Okay, number 8, same idea. 8 times 6 equals 3x times x. Now x times x here becomes x squared, so I have 3x squared. And then 8 times 6 is 48. Divide by 3 on both sides. 48 divided by 3 is 16. And then x squared, square rooted both sides, becomes 4. 16 divided by, or 16 square rooted is 4. So that's a nice number we got there. Good. Okay, so that's all of the first side. I know that it's bringing in this idea of, factors and squares and all that stuff, which maybe is a little bit not as refreshed in our brains from last year. But just try your best, do the best you can. I don't think I'm going to test you over too much of this concept. The main thing I'm going to really look at is if you know the idea of those two parts of the chord, the products of them are equivalent. Okay, so let's add a little bit more to our notes. And what we're going to look at are these segments created by your secants and tangents, or just secants intersecting on the outside of the circle. So last time we talked about how we can find this angle, and we can find the angle on the outside of the circle. But this time we're looking at the actual measurements and lengths of the parts of the segment. So the big idea here is if you have two secants that are intersecting on the outside of the circle, then the products of the entire length of the secant, so the entire length times the part that's outside of the circle, when you multiply them, is equivalent to the entire length of the other secant and the product of it with the outside part. So if I were to label this, A, B, C, D, E, what I'm saying here is AC, this whole length, times BC is equivalent to EC times DC. Okay, so the entire length of the secant the product of the entire length of the secant and the part outside the circle is equal to the product of the entire length of the other secant and the part outside the circle. Okay. All right, so let's test this idea out with some problems. So number 2 is our first example where we have the parts. So before you actually work out your equation, you really do need to find the sum of the entire length first. And so 16 plus 26 is 42? Okay, so 42 times the part outside the circle is 16. is equivalent to, oh, this entire length. So I'm going to actually have to just add that as a little, write that as a little expression, 18 plus x times 18. Okay. So working this out, I'm going to get some big numbers. 42 times 16 is 672. And then 18 times 18 is 324 plus 18x, because I'm distributing this into all the parts. And so I'm going to subtract that 324 from both sides. And now I have 348 equals 18x. Divide by 18 on both sides. And x equals a decimal rounded as 19.3. Ooh, not pretty numbers, right? So let's try number 3. These tell me that these two parts are congruent. So I'm going to write this as the entire length is 16, because 8 plus 8 is 16. So I have 16 times 8 equals 2x plus 6 times 6. So let's distribute this in. 16 times 8 is 128. 2 times 6 is 12x plus 36. Subtract 36 from both sides. I get 92. Now I have to divide by 12. And again, I get a decimal. So divide by 12 on both sides, and that rounds up to be 7.7 is x. Okay, let's talk about our next part where we have a tangent and a secant intersecting. So we're going to add that to our notes. I'm going to clear this off so we have more room. And I'm going to draw a picture here, and I would definitely recommend maybe you draw a picture as well. So let's label these parts A, B, C, D. So when you have a tangent and a secant intersecting, what's interesting is that actually the tangent squared is equivalent to the sum of the entire length of the secant and the part outside the circle. So similar to the other one, outside the circle. So if you want to write this out as your explanation, you could do that. But I'm going to describe that. AB squared equals BD times CB. Okay. So what's different with this and the other problem is instead of saying like finding the product of the two parts of your secant, whereas you don't have two parts here. So all we're doing is we're squaring the tangent. Okay, so let's go back and do some practices. So looking at number 1, we've got our tangent and it's 3.3. So I'm going to say 3.3 squared equals the product of the entire length times the part outside the circle. So I'm going to say 2.2 plus x times 2.2. So I have to distribute this. Love these decimals, don't I? So let me actually work this out. 3.3 squared is like 10.89. And then 2.2 times 2.2 is 4.84 plus 2.2 times x, 2.2x. Okay, so we can subtract what we can. So subtract 4.84 from both sides. And you have 6.05 equals 2.2x. Now I can divide by 2.2 on both sides, and I get 2.75 as my answer. Or if I round it to the nearest tenth, like my instructions say, 2.8. Equals x. Okay, so let's try number 4. We've got a tangent and a secant. So my tangent is 13, so I'm going to do 13 squared equals the sum of my entire length times the part outside the circle. So I need to distribute this into my what's in the parentheses. 13 squared is 169, and 9 times 9 is 81. 9 times 5 is 45x. Okay, 9 times 5x is 45x. So subtract 81 from both sides. 88 equals 45x. And then divide by 45. And your answer is like 1.95. Rounded to the nearest tenth is about 2. So x equals 2. Okay, going back to our secants, same idea. We've got to add this all together. So I really don't have a way other than just to write it out. 6 plus 4x times 6 equals 6 plus x plus 3 times 6. Okay, so let me simplify what's in here first. 6 plus 3 is 9. 9 plus x is in parentheses times 6. And then I'm going to distribute this. 6 times 6 is 36. 6 times 4x is 24x. So 36 plus 24x. Distribute this. 6 times 9 is 54 plus 6x. So here, for once I don't have any squares, I'm going to combine my like terms. So I might subtract 36 from both sides. So 54 minus 36 is 18. And then I'm going to subtract 6x from both sides. And so 24 minus 6 is also 18. And so 18 divided by 18 is just 1. How nice. 1. X equals 1. Last problem. Maybe this will be the easiest one. We'll find out. Okay, maybe not. Okay, so this entire length, 8 plus 2 is 10. So now we have 10 times 8 equals 11 plus x times x. Okay, we've got to distribute our x in. And so we have 80 equals 11x plus x squared. Okay, I'm going to rearrange this a little bit and make this into my equation where I can factor, because I've got an x squared plus a number times x plus another number. So I'm going to make this x squared plus 11x minus 80. I'm going to subtract 80 from both sides and think through, do I have factors of negative 80 that equal out 11? So what, I have 8 and 10, 2 and 40, 5 and 14, I believe. No, 16. Okay, 5 and 16 actually look like if I added these together or subtracted these, I would get 11 somehow. So I think if I make 5 a negative, then I have 16 minus 5, which is a positive 11. So my factors are x minus 5 times x plus 16. And so when I set these up equal to 0 and work out what each x value would be, it looks like x equals 5 and x equals negative 16. And so because this one's positive, x equals 5 here. And so x equals 5. And that's my answer. All right, man, that was kind of a crazy lesson, not because the actual idea behind our work was hard, but because we had to, factor stuff out, and that's something we haven't done in a long time. So if you remembered how to do that, props to you. You're doing awesome. If you don't really remember that, I've attached a video on RenWeb that goes over factoring, so that way you can refresh your memory because you will see it again next year. So it's good for us to refresh our memory a little bit. But that's it for today. Your homework is from your book, so make sure you check RenWeb, but your homework is from your book this time.